Before we discuss various types of nonparametric inference, let's take a brief moment to review the inferential techniques that we've discussed so far in class. To go through this review, we'll consider the two different types of sampling schemes that we've studied, independent samples and dependent samples. So let's start with the case that you've taken independent samples from two populations. When you take these samples, there's two different types of variables that we've discussed thus far. You could take samples of interval ratio data, or you could take samples of ordinal data. So for right now, let's start with the case that interval ratio data has been collected. If the variable of interest was interval ratio in nature, then there are certain summary statistics that can be applied to that data, such as the mean, the median, the standard deviation, among others. Now, the goal that we've had with this data so far was to compare the two population means from which we sampled, and to do that we would use a t-test. Now, remember, the t-test that we've talked about require that we sample from a normal population. So you'll see in our box we have that normality must be assumed. The easiest way that we have to check that our samples came from a normal population is to create a histogram of that variable for each of our two samples and assess to see whether that histogram follows approximately a symmetric bell-shaped curve. If the assumption of normality seems to be met, we can continue to do the t-test or t-confidence interval to make an inference about the two population means. Now, when looking at that confidence interval or hypothesis test, there were actually two different approaches to take. The first assumed that the populations from which we sampled had equal variances, and the second assumed that your population variances were unequal. To check this assumption, we could look at our sample standard deviations and verify that twice the smallest standard deviation is greater than the largest. If this assumption is met, then we can proceed with the equal variance t-test. If twice the smallest standard deviation is actually less than the largest standard deviation, we have to proceed with the unequal population variance t-test. Now, keep in mind that we are only using the t-test because the interval ratio data that we collected appeared to be normally distributed. So a natural question is, what happens if you collect interval ratio data and then it's not normally distributed? So what we've got now is we have these nonparametric inferential techniques that still allow us to make some type of inference about that data. In the case where independent samples were taken, the name of the test that will be used is the Mann-Whitney test. Here's the critical difference between the t-test and the Mann-Whitney test. While the t-test compared our two population means, the Mann-Whitney test will compare our two population medians. So there's a brief summary of what can be done with interval ratio data, but we can also consider ordinal data. Now, keep in mind that when our data is ordinal, we can't summarize that data by calculating a sample mean, but we could summarize that data by calculating a sample median. So it stands to reason that if the Mann-Whitney test is comparing population medians, the Mann-Whitney test would be appropriate to apply to ordinal data, and that's indeed the case. Now, independent samples were not the only type of samples we discussed. We also considered dependent samples. So when our samples are dependent, there's some type of pair that's created. The pair can be created by matching on some external variable such as age, height, weight, gender. It can also be paired naturally by looking at pre-test, post-test measurements, a before-after study. Anything in this line is going to create pairs of observations. So let's consider dependent samples much the same way and start with the case where the variable in question is interval ratio in nature. So if interval ratio data has been collected, again, that implies you have some type of numeric data, so we can consider talking about means and standard deviations, and we could compare the mean difference between our pairs of samples by looking at a t-test. Again, the t-test that we're going to consider, we must assume that the differences in our observations are normally distributed. Again, this can be checked by creating a histogram. But much like with independent samples, if we fail to meet that assumption of normality, it would be nice to have an alternate form of inference to go to in order to still make some type of generalization about our population. In the case of dependent samples, the nonparametric analysis that can be done is the signed rank test. Now, just like before, the t-test is comparing the mean difference, while the signed rank test will compare the median difference. And much like before, if you can deal with the median in the signed rank test, it seems appropriate that you could also consider dependent samples of ordinal data. So if we collect an ordinal variable from dependent samples, that data can be analyzed using the nonparametric signed rank test. So you'll notice in both of the slides, the one variable type that's missing thus far has been nominal data, and that's coming soon. So stay tuned for the nominal data inferences